Hello everyone. In this video we're going to talk about the effective value of alternating current, and we're going to solve some problems on the dynamo. So what the meaning of effective value of alternating current? As you know, when the current passes through the wire, there are some losing and the electric energy as heat energy, as we call it thermal effect, as you study. So always the E effective will be smaller than E max, and always E max is greater than E effective, because that's different, because some of this energy lost as heat energy. So for example, if the E max 100, the E effective will be 90 maybe. Okay, this just certain numbers. Let's see some example to see how we can deal with E effective. Okay, the scientists by experiment found out this relation. Okay, the question say the dynamo generates alternating current. Its frequency is 50 over 2 pi. Okay, this is the frequency F, and it is effective value of alternating current. Okay, this is E effective. Okay, the coil length and width. Okay, from this two dimension we can find the area. Respectively, the coil has two turns. This is the number of coil turn is 200. Calculate the maximum value of EMF. Okay, we already know that we can use this relation, E max equal N B A omega, but in this case we can't. Actually we can't. Why? Because we didn't know the magnetic field density Tesla. Okay, so we have to use another relation to solve this question. The another relation will be this relation. So we need to find Emax. So by move root 2 to another side like that, Emax will equal E effective time root 2. So Emax equal E effective time root 2 will be 200 time root 2 volt. Okay, you can just keep it like that without write a decimal number. So the question number 2, magnetic field density. So now we can use this equation, E max equal N B A omega. Okay, but before we use this one, we have to find omega, and we have to find the area. Okay, always you have to convert the area unit to the meter. So the area here comes with centimeter, 60 centimeter and 20 centimeter. So by convert it to the meter, it will be 0.6 and 0.2. And we all know to find area of rectangle we make length time width. So 0.2, 0.6 times 0.2 equal 0.12 meter square. Okay, this is the area. What about omega? Omega, as you know, we can find it from this relation. We have already two relation to find omega, but in this relation we have the frequency, so we can use this relation to omega equal to by f, and the frequency is 50 over 2 pi, so we can remove 2 pi together, the remains will be the 50. Okay, now we can substitute the value here in this relation, but before that we have to move all of this, sorry, we have to move the n and a and omega to the another side. So b will equal E max over n a w equal E max is 200 root 2, and number of turns is 200, area is 0.2, 0.12, and omega is 50, equal, on the calculator will give us, okay, on calculator it will be 2.35, 0.235 Tesla, the unit of the magnetic field density. So now we solved question number 1, this one and this one. So question number 3 is the maximum value of when the coil rotates 1/6 cycle. Okay. Okay, if you remember from the last video, we talked about how we can find omega. Okay. We say that we can calculate the theta from two relation. Okay, and one of this relation was theta equal omega t equal number of rotation. Okay, number of rotates, okay, time 2 pi, which pi here, pi equal 180, because we're going to find theta. So number of rotates is 1/6, so 1/6 time 2 time 180. The answer will be, on the calculator, will be 60. So this is the theta. We can now use this equation, if you remember it, which said E equal E max, okay, time sine theta. Now we have theta is 60, so we just substituting the numbers. E max is 200 root 2 time sine 60 equal, okay, sine 60 is time 200 time root 2. Okay, the answer will be 244 volt. 0.9 actually. Okay, okay, you have always to know that Emax always greater than E effective and E and normal E. If you make on the calculator 200 time root 2, you will find out that time root 2 Emax equal, I just converted from the root to the normal number, Emax equal 228 volt. As you see, Emax greater than normal E and greater than the E effective, which was 200. Okay, the last question. Let me remove this quickly. Okay, last question is the maximum value of EMF when the coil rotates around the parallel axis to the length of its width with velocity 0 point. Okay, with this velocity 0.20 sorry, not 0, 24 meter per second. So how we can solve this one? If you remember the relation, you have now to find the relation between the omega circular velocity and linear velocity. Okay, who remember the equation? So the omega was equal the linear velocity over the radius. Okay, so linear velocity here is 24. Okay, what about the radius? Okay, now we talk about the radius of rotation. Let me show you how to understand what the radius of rotation. So if we have the coil here, as you know, the coil will rotate in this direction, and while the coil rotates, it will, if you look for it when it rotates, it will seem like that, like that. Okay, because it rotates, it will seem like that. So the radius will be what? The radius will be the half of the, yes, the half of the weights. Okay, this is the length and this is the weights, so the radius will be the half of the weights. Okay, in this question the weights was 0.2, so the radius will be 0.1. So omega here will be 24 over 0.1. 24 divide 0.1 equal 240. Okay, now we gonna to substitute the omega in the summation. Emax equal NBA, okay, time omega. So N is 200, B is 0 times 0.235 time A is 0.12 and omega is 240. So it will be on the calculator time 0.12 time 0.235 time 200. Okay, it will be 1353.6 volt. Okay, 1353.6 volt. Okay, this now we finished this question. Let's move to the last one. Rectangle coil. Okay, from this we can find the area. Has, okay, this number of the coil turn, tensor number axis with. Okay, from here we can find the frequency equal 600 over 60, because we convert minute to second, so it will be 0 with 0, it will be 10 xz. If the EMF is okay, so this is E equal 2.2 volt. After 1/2 cycle, find the magnetic flux. Okay, I think we can you can find it. You can work with yourself to find it. This will be homework, and good luck. My best wishes. Goodbye.